Students, welcome to Sheikh Mathematics classes. So today we start exercise 7.10 problem number 1. First problem 7.10 given evaluate the integrals in exercises 1 to 8 using substitution. So this is our problem. Number 1 given 0 to 1 x square plus 1 dx. We solve this problem by using substitution method. Now solution is start. So solution start given 0 to 1 x square plus 1 dx. This is our problem. We consider this denominator equal to z. Let x square plus 1 equal to z. This denominator we consider z. Now if we differentiating both sides with respect to x, we differentiating both sides with respect to x. So this will be twice x dx of 1 is 0 dz dx, and twice x dx equal to dz. X dx equal to 1 by 2 dz. So we get this one. Now our problem given the limit given for x, we convert the problem in terms of z. So we interchange our limit also. So if x equal to 0, lower limit is 0, then putting here z equal to 0 square plus 1 equal to 1. And upper limit given 1, if x equal to 1, then z equal to 1 square plus 1 equal to 2 we get. We interchange our limit also. Now we write this integration 0, 0 means we write 1, for 0 we get 1, this is 1, and 1 for 1 we get, when x equal to 1 we get z equal to 2, and this denominator we consider z, because x square plus 1 we consider z, and x dx, this is 1 by 2 dz. So this will be 1 by 2 dz. X dx equal to 1 by 2 dz. 1 by 2 is constant. His position outside from this integration, 1 to 2 dz by z. And this is 1 by 2 dz by z, this one log z, and this is 1 to 2 we get. Dz by z, direct formula we get log z, because we know integration dx by x equal to log of x, modulus of x plus c. So we putting the upper limit, this is log 2, upper limit is 2, minus lower limit, this 1 by 2 log 2, and log 1 is 0, 1 by 2 log 2, and this is our answer, 1 by 2 log 2, this is the final answer. So very nice solution, very easy. Consider problem number 2. Problem 2 given 0 to pi by 2 root over sin phi cos to the power 5 pi d phi. This problem is given. Now I want to solve this problem. Now solution is start. I rewriting this line 0 to pi by 2 root over sin phi cos to the power 5 pi d phi. This is 0 to pi by 2 root over sin phi cos to the power 5 pi, phi we can write cos square phi whole square into cos phi d phi. Just cos to the power 5 given, we write e square whole square, this is 4 and this 5. And this will be 0 to pi by 2 sin phi. Cos square means 1 minus sin square. Cos square phi equal to 1 minus sin square phi. Cos phi d phi. We know this formula, cos square theta plus sin square theta, or we can write phi also, this is 1. So cos square phi equal to 1 minus sin square phi. So we replacing cos square and putting sin square, because here also sin given, sin we write same ratio. Now let sin phi equal to z, or we can consider u also, and d phi sin phi dz d phi. We differentiating both sides with respect to phi. D phi of sin phi, this is cos phi, and this d phi multiplying left hand side, and this is dz. We get this. Again we interchange our limit, because our limit given 0 to pi by 2, this one given 4 phi, but we convert the problem in terms of z. Now we interchange our limit. If phi equal to lower limit is 0, if phi equal to 0, then z equal to sin 0 equal to 0. So sin phi, z equal to sin phi, sin 0 equal to 0. If phi equal to pi by 2, then z equal to sine of pi by 2, and sine pi by 2 means 1. So we interchange our limit also. This is 0 to 1. For 0 we get 0, for pi by 2 we get 1. And this one root z, sin phi we consider z. And this is 1 minus z square whole square. And cos phi d phi means dz. We get this. Now this is a minus b whole square formula. We know from lower class, this is the second formula in our life. A minus b whole square equal to a square minus twice ab plus b square. We know this formula. Now using this formula we get 0 to 1, and root z means z to the power half. This is 1 square is 1 minus 2ab, that means 1 square 2 into 1 into z square plus z square whole square dz. We get this one, and this equal to 0 to 1 z to the power half 1 minus 2z square plus z to the power 4 dz, and we multiplying all the terms by z to the power half. This is 0 to 1 and z to the power half 2z to the power half into z square plus z to the power half into z to the power 4 dz. We get this. So this is 0 to 1 z to the power half z to the power 2 plus half plus 2, this is 5 by 2 if we adding, and z to the power half plus 4 9 by 2 dz, because if base are same, power will be 8, 1 plus 2, this is 2 LCM, 1 plus 4, this is 5 by 2, we get this is 5 by 2, and half plus 4, this is 2 LCM, 1 plus 8, 9 by 2, we get this one. Now we integrate all the terms. What we get? 0 to 1 z to the power half dz, 2 constant outside, 0 to 1 z to the power 5 by 2 dz plus 0 to 1 z to the power 9 by 2 dz. We get this. But we know this formula. The first formula is integration x to the power n dx. This equal to x to the power n plus 1 by n plus 1 plus c. We know this formula. Integration x to the power n equal to dx equal to x to the power n plus 1 n plus 1. So here n means half, here n means 5 by 2, here 9 by 2. So this will be z to the power half plus 1 by half plus 1. This is 0 to 1 minus 2 z to the power 5 by 2, 5 by 2 plus 1. This is 5 by 2 plus 1 and 0 to 1 limit, and z to the power 9 by 2 plus 1, 9 by 2 plus 1, 0 to 1, this, and this value will be z to the power 3 by 2, 3 by 2, 0 to 1, 2 z to the power 7 by 2, 7 by 2, 0 to 1, and z to the power 11 by 2, 11 by 2, 0 to 1. Now this becomes in numerator 2 by 3 z to the power 3 by 2, 0 to 1. 2, 2 by 7 z to the power 7 by 2, 0 to 1. 2 by 11 z to the power 11 by 2, 0 to 1. We get this. Now putting the upper limit 2 by 3, 1 to the power 3 by 2 minus 0 to the power 3 by 2. 4 by 7, 1 to the power 7 by 2 minus 0 to the power 7 by 2. 2 by 11, 1 to the power 11 by 2 minus 0 to the power 11 by 2. So ultimately we get 2 by 3 minus 4 by 7 plus 2 by 11 we get. So we get this. This is 1, this is 0, directly 1, this is 1, this is 1, then we get this. And taking LCM, if we LCM, taking LCM, this multiplying, we get 231. And divide this in this LCM, we get 77. 77 into 2, 154. And we divide this in LCM, this is 7 cancel, then 33. 33 into 4, we get 132. And 11, 21 times, 21 into 2, we get 42. So if we calculate this, then denominator remains same, 231, and if we subtract this and adding this, we get 64. So this is our final answer. So dear students, this is very nice solution, and solution is very easy, not difficult, and just you have to know how to substitute our values. So we substitute sin phi equal to z, and by practice, then integration means interest. So we ultimately get interest. Without practice, integration is difficult. With practice, we can solve in another method also, and different methods we can use. If you are feeling easy, I hope this solution you are feeling easy. If you are feeling easy, then please like this video. If you are new in my channel, then please subscribe my channel and click the bell icon. Thank you.